Hey students, today we're going to talk about solubility rules and how to write balance equations with the states of matter. So these are the solubility rules, and these are on the back of the periodic table, so you don't have to memorize them. All common ions of the group 1 elements and ammonium ions are soluble, and these should actually say the metals, not the group 1 elements. So talk about lithium all the way through francium and anything that you have ammonium in. So ammonium is your NH4. Those are going to be soluble. All common acetates. Acetates are your C2H3O2 minus, and nitrates, NO3 minus, are all binary compounds of group 17. Are all soluble. All binary compounds of group 17 other than F with metals are soluble except those of silver, mercury 1, and lead will be insoluble. All sulfates, which is sulfate is SO4 minus 2, are soluble unless you're paired up with barium, strontium, lead, calcium, silver, or mercury. Those would be then insoluble. And then, except for those in Rule 1, all of these will be insoluble. So Rule 1 kind of trumps for this. So here we've got PbCl2. So we need to figure out, is it soluble or not soluble? So Cl is group 17. It's right down there, and it's in group 17. And then Pb is your lead. So group 17 is talked about in rule number 3, and since this is lead, that means it's going to be everything soluble unless it's paired up with these. So this will be insoluble, so it's not going to be soluble. BeSO4, well, sulfate that's sulfate. So sulfates are soluble except those with barium, strontium, lead, calcium, silver, and mercury. Well, Be is beryllium. So beryllium is not one of those exceptions, and so that means it's soluble, and that's rule number 4. NH4, well, this is ammonium. That is hydroxide. So you could either use rule 1, which tells you ammonium are soluble, or you could use rule 5 that says except for those in rule 1. Hydroxides are insoluble, but this, since it's in rule 1, that works as well. The main one is rule 1. So 4 compounds, soluble is equal to aqueous, insoluble is solid, water is liquid, CO2 is gas. And then for elements, you're going to use the chart. So we have a couple of examples, and then we'll go through this. So bromine is right there. That's an element, and that's part of Brinkelhoff, and so it needs a 2. And since it's an element, we're going to use the chart. It is blue, so that tells you it's a liquid. Plus rubidium chloride. So rubidium is right here. That's in group 1. So it's plus 1. Chloride is in group 17, and it's minus 1. So we will combine them. So RbCl, because they're both 1s. And then because rubidium is in group 1, it's soluble. For soluble, we're going to write AQ. So AQ. Then this is a single replacement reaction. Bromine is a nonmetal, so it replaces with the other nonmetal. So Cl will be by itself. Cl is in group 17. It's green. Green tells you it's a gas. So it needs to have a gas behind it. It's also part of Brinkelhoff and an element right now, so it needs to have a 2. Plus, your rubidium will now combine with your bromine. Bromine is a minus 1. So plus 1 minus 1, we'll get RbCl. Once again, Rb is group 1, and group 1 is soluble, so soluble will write AQ. And then, of course, you still need a balance. So I have 2 bromines over here on the left. Oh, this was supposed to be a BR. The RB and the BR combined. So 2 on the left, 1 on the right. So I'm going to put a 2 here. I have 1 RB on the left. I now have 2 on the right. So I'm going to put a 2 here. I have 2 Cls on the left, 2 Cls on the right, so that's good. Okay, strontium nitrate. Strontium is in group 2. That's Sr plus 2. Nitrate's on the back of your periodic table. That's NO3 minus. It reacts with lithium. Lithium is in group 1, right there. That's a plus 1. Sulfide is right here. It's in group 16, so that's an S minus 2. Okay, so strontium nitrate, the formula will be Sr, and then cross that 2 over, so N2. To figure out it, that's a compound. So we have a nitrate, so that's going to be soluble. So we'll put an aqueous behind it. Plus your Li and your S, that 2 needs to cross over, so we'll get Li2S. We've got lithium, which is your group 1, so that's going to be soluble, so that will be an aqueous. Double replacement, so switch your 2 metals, so the lithium will now combine, your lithium and nitrate combine together, plus 1, minus 1, so you have to cross them out, cross them over. Group 1, Li, so it's going to be plus Sr and S, they're both 2s, so those 2s would cancel out. So we just get SRS. S is a sulfide. So sulfides are right here. It says, except for those in Rule 1, sulfides are insoluble. Well, Sr is not part of group 1 or ammonium, so this one will be insoluble. So this will be solid. Insoluble is a solid. Then you want to balance. I have 1 Sr on the left, 1 on the right, so that's good. I have 2 nitrates on the left, 1 on the right, so I'm going to put a 2 in front. I have 2 Lis on the left, 2 Lis on the right, so that's good. 1 S and 1 S, so that's good.